Okay, here's a video containing the solutions for step-by-step 35 and 36. I'm going to skip part A first. That's a related rates problem. I'll come back to that one at the end. I'm going to go to our applied maximum minimum problems here. Find the dimensions of the rectangle that gives the greatest area. Here's parabola 16 minus x squared. So we have a point labeled there, but I'm going to relabel it as x comma 16 minus x squared. So then the area of my triangle would be, this would be 2x, and this would be 16 minus x squared. So the area of the triangle would be equal to 2x times 16 minus x squared. I'll simplify that to make the calculus a little easier. Okay, and then since I want the maximum area, I'll take the derivative of that and, that's 6. Set it equal to 0. So x squared is equal to the square root of 32 over 6, or 16 thirds. Sorry, I already solved for x there. And it could be plus or minus, but of course the plus or minus x value here gives you the exact same rectangle. So what are the dimensions? I guess it would be 2 of those, and the square root of 16 is 4, so I guess you could write that as 4 over the square root of 3. So the dimensions would be 2x, or 8 over the square root of 3, by, and what would the height be? The height would be the y value here. The square root of 16 thirds squared is 16 thirds, and 16 minus 16 thirds is the same as 48 thirds minus 16 thirds, which is 32 thirds. So dimensions of the rectangle would be 8 over the square root of 3 by 32 thirds. Not a square, notice. If you were hoping for that to be true, was not. Okay, now the parabola is rotated about the x-axis to form a paraboloid. That's like a dome. And a cylinder is inscribed in here. So basically we've got the same thing. We've got this rectangular cross-section. It's just that now this is like the radius of the cylinder, and this is like the height of the cylinder. So we want the radius and height of the cylinder of greatest volume. Volume of a cylinder is equal to pi r squared h. So ours would be pi times, the radius is just the x value, x squared, times the height is the y value, which is 16 minus x squared. And a little simplifying of that. That would be 16 pi x squared minus pi x to the fourth. I want the maximum volume, so I'll take the derivative of this and set it equal to 0. That's 32 pi x minus 4 pi x cubed. And setting that equal to 0. See what we can factor out here. Looks like there's a 4 pi and an x. That leaves an 8 behind here, and x squared here. So the critical points here would be at x equals 0. Of course, that can't be our answer. That's a cylinder with a radius of 0. That's no good. And plus or minus the square root of 8, which you could leave it as the square root of 8. 2 is on the square root of 2, same thing. Again, whichever x value doesn't matter, so the radius would be 2 square root of 2. The height is 16 minus that, and 2 square root of 2 squared is 8. 16 minus 8. So those are the dimensions, the radius and the height that they're looking for. Okay, let's go back up to the part A. This is a little different than what we've been talking about in this chapter, but see if we can do it. Our area function is, I'm borrowing this from part B, right here, 32x minus 2x cubed. Now, we're talking about, how do you know this is related rates? Because we're looking constant rate of change of the x coordinate, and then they're asking for another rate of change. So two different rates of change. This is clearly related rates. So let's see if we can remember how to do that. Remember, that's like implicit differentiation. Every letter we hit, we get a d whatever dt. The derivative of a is dA dt. The derivative of 32x is 32 dx dt, minus the derivative of this is 6x squared dx dt. We're looking for the rate of change of the area, and we know that the x-coordinate increases at 1.5 units per minute. That's dx dt. And find the rate of change when x is 2. So I think we just need to plug in these values. So 32 times dx dt is 1.5, minus 6 times 2 squared is 4, times dx dt is 1.5. 1.5 32s is 48, and 1.5 24s is 36. So 12 units squared per minute. That's what's happening there. All right. I wouldn't expect that you'd see that on a test, but you never know. Okay, last one. Price of a share of stock in dollars over a week is given by this function. This is a price where t is measured in days 0 to 5. Find the average rate of change. That's an actual slope of a secant line. In other words, a slope using two genuine points, not calculus, over from 0 to 5. So let's find those 2 points and find the slope. So 0, comma, what do you get when you plug 0 into this? The square root of 2 times 0, that's 0, plus 1, the square root of 1 is 1. The cosine of 0 is 1, so I've got 1 plus 2 plus 20. That'd be 23. And then, oh look, calculators are allowed here, so you can do that if you want to. And I guess we'll have to do that here because cosine of 5 is not anything nice. So let's see. Make sure that I am in, oops, radian, uh-oh, I was in degree mode. Must have been doing physics. So put it back. So let's see, that would be the square root of 2 times 5 plus 1 is 11, plus 2 times the cosine of 5 plus 20. So it's at $23.88. I'll run to the nearest cent. Okay. So you can see when you're allowed to use your calculator, you really are going to need it. So the slope here is y minus y, which is 88 cents, divided by 5 minus 0. So let's see what that is to the nearest cent. would be about 18 cents. So those are the correct units, right? Oh no, that's not the correct units, because this is dollars per day. That's 5 days. So it's 18 cents per day would be the correct units, because this is a rate of change. All right. Apply the mean value theorem on P, 2P on this interval, and explain the result in the context of the problem situation. Okay, well, the mean value theorem says that the average rate of change, which we just found, that's that slope, must be equal to the derivative for some value, and that value better be in between 0 and 5. So we need to find the value, or the derivative, sorry. P prime of t is using the power rule and chain rule. Don't forget to multiply by the 2 inside there. Plus 2 times negative sine t. Derivative of 20 is, is 0. Right? And we need to set that equal to 0.18. Now, that's not any kind of equation you can solve without a calculator. So we need to solve this with a calculator. The 1/2 and the 2 cancel out, so I'm going to end up with 2t plus 1 to the negative 1/2 minus 2 sine t minus 0.18 equals 0. Why did I move everything to one side? Because now I'm going to graph that and find the zeros. So y equals 2x plus 1 to the negative 1/2 minus 2 sine x minus 0.18. I'm expecting it to be somewhere between 0 and 5, so I guess the standard window should be all right. And explain the result. So let's see. It looks like there might be another one there. I don't know if that's at 0 or what's going on there, but let's I'm going to do a Z box. Let's look. From 0 to 5. Looks like I got 2 values. So second calculate 0. There's one in between 0 and 1, so I'll put in left bound 0, right bound 1. And that's at equals 3.0 or 0.31. And second one looks like it's right around 3, so in between 2 and 4 anyway. Second calculate 0 in between 2 and 4. At 3.0. I really should round to 3 decimal places there. I'm sorry, because that's what the College Board likes us to do. So 3.04, actually 4 rounded correctly. And let me just go back and fix that one. The other one was between 0 and 1. So it would be 0.308. Let's write it. Let's do it right. Got to get in the habit of doing that now. All right, so that's messy. Okay, so what does that mean? Explain the result in the context of the problem. It says that at time 0.308, which I guess is sometime in the first day on Monday, and time 3.044, which would be sometime on Thursday. 3.044. The rate of change, in other words, p prime of t, is equal to $0.18 per day. So twice during that time, the actual rate of change of the stock was equal to the average rate of change. That's what it means. That's what the mean value theorem says. We're guaranteed to find one, but there could be more than one. And last, what value of t over the 5-day period is the price of the stock increasing the fastest? So we want to maximize the increase. In other words, we want the maximum of the derivative. In other words, we want to find the second derivative and set it equal to 0 and do a little sign analysis of that. Okay. So here is the function. Actually, that's not quite. We took that here and we set it equal to 0. So the derivative was, when we simplified it, it was 2t plus 1 to the negative 1/2 minus 2 sine t. Right? So the second derivative, p double prime of t, would be equal to negative 1/2 is 2t plus 1 to the negative 3/2 times derivative of what's inside minus 2 cosine of t. So where is that equal to 0? I'll find you our number line thing. We only care about from 0 to 5, right? So let's get this out of here and let's graph this. The 1/2 and the 2 cancel out, and it doesn't matter if you can enter them into your calculator or not. It doesn't matter. So that's negative 2t plus 1 to the negative 3/2. If you put it in as 3/2, you need it to be in parentheses. Minus 2 cosine x. Oops, what's going on there? All right, and let's go ahead and graph that. So it looks like it goes from negative to positive to negative, right? And we're looking for where it's increasing the fastest, so we're looking for a maximum. So let's see, this is decreasing to increasing and then increasing to decreasing. So it's this spot here where it crosses. That would be our maximum, right? This is decreasing, increasing, and then decreasing, so this is the maximum here. Yeah. And let's find that value. That looks like it's between 0, 1, 2, 3, 4, between 4 and 5. So and calculate at 0 is in between 4 and 5. That's at t equals 4.697. And we should check and make sure. Let's see if we have it already. Have we found the rate of change? We really should also, because this is on a closed interval from 0 to 5, we should check here also. I'll leave you to check that yourself. But this is the other candidate, since it's decreasing from here and then increasing and decreasing. This could also be the maximum. You got to check the endpoints. It couldn't be this one because it was decreasing up until 5, but check 0, check t equals 4.697. Where would you check them? We're trying to find the biggest increase, so you would plug those values back into our derivative and see which one gives you the biggest value? I think probably it's this. But you can check that yourself. All right.